Thank you. Good afternoon. And first of all, I would like to thank Ruben for Bogan, the volunteers that are here, the local astronomy association, the city government of Genk, and our sponsors. Can we acknowledge them with a hand? I think you would agree with me that this is an exceptionally well organized conference. Too bad that they couldn't order lower temperatures for the summer, but that's our new reality. Okay, let's see. Okay, as many of you know, together with my wife, Holly White, we operate a website called GreatAmericanEclipse.com. GreatAmericanEclipse.com provides comprehensive information about coming eclipses. We do have an emphasis on American eclipses, but we also serve information about eclipses around the world, including the coming eclipses in South America. A special feature of our website is that we think that we offer superior eclipse maps, which we are able to do because of my background. I have a 30-year career in the GIS industry. GIS stands for Geographic Information Systems. If you're not familiar with that, just think smart maps, and that's what GIS is all about. So I run the creative side, and Polly does much of the operation of the rest of the website and the items that we offer on the website. One comment I would like to make about this too is, what do we mean by Great American Eclipse? Recently there's been some unfortunate rhetoric coming from the president of our country. We don't mean that America is the most fantastic place on earth and so forth. As you'll see later on by Great American Eclipse, we're referring to the special circumstance of the 2017 eclipse that bisected the country and that was so accessible to so many people. That's what we mean by Great American Eclipse. So my central thesis in this presentation is that eclipse maps equals science plus artistry. These are two maps, one from the past and one that I made. The map on the left is about 150 years old. It comes from the French almanac Connaissance du Temps. Forgive me if I mispronounced that. But of all the almanac authorities that have been producing eclipse maps, I think that these were the finest. Just stunning maps of exquisite beauty and precision and information content. These days, with computerized mapping, it's easy for many people to make maps, but many of the maps leave something to be desired in their artistry, and I feel strongly that an eclipse, a total solar eclipse, is the most beautiful thing that we can see in nature. So the maps should also be beautiful, don't you agree? So that's my work, is to make the maps accurate, scientific, express the right level of information, and to be beautiful. That's a worthy goal in itself. Now, the very first eclipse map is a rather remarkable document. This was done relatively soon after the publication of the Rudolphine tables, which was the first modern ephemeris. So the Rudolphine tables enabled Erhard Weigel in 1654 in Jena, Germany, to produce this map. And if you compare the old map with the modern reproduction that I created, you'll see that it's a rather good match. It's a strikingly good match for the year 1654. If you're like me, I am still astounded by the predictability of an eclipse map. And to go back this far in history, I think is interesting. I'll point out a couple of interesting features about this map. It's a static map, but if you look at it carefully, it's actually an animation. It shows the eclipse at 5 different points. It shows the exterior contact of the penumbra, and it shows the various contacts of the eclipse, and the midpoint of the eclipse, which was in the Crimea. And if you compare to that map, you'll see a rather good match between the two. After 1654, there were maps in 1676, 1699, but around the year 1706, there was a great flourishing of eclipse maps across Europe. And this was due to 2 major solar eclipses that captured the scientific imagination and that were widely seen by the public and that were predictable in advance. Perhaps the most famous early eclipse maps were those done by Edmund Halley in 1715 and 1724. I won't go into all the details, but these maps were again very accurate for their time. The first map that Edmund Halley created had an accuracy of roughly 30 kilometers or so. It was roughly 30 kilometers off the track. And one thing he did in his map, you can't see it in this instance, but there's some text on the bottom, and the text was a solicitation for citizens to report whether or not they saw the eclipse from their location. So Halley took these reports from citizens and revised the map to about 3 kilometers accuracy. So from the early 18th century, we started enjoying very accurate eclipse maps. You'll see on the map on the right side, there's 2 paths that cross. That's the 1706. I'm sorry, the 1715 and 1724 maps. This map is interesting because it shows a degree of sophistication in eclipse cartography, but what I like about this map is that it shows that we can understand the geography of the eclipse at a far greater level of detail than we understood the shapes of the continents, particularly North America. So that's a nice contrast in this map. This map is starting to show more information. This is very helpful information for a number of locations listed that show the appearance of the eclipse at maximum eclipse. Another beautiful map from 1748. This map is the first eclipse map from the New World. And it's somewhat crude, but I've analyzed this map and it's broadly very accurate. There's some interesting details about this map that I can discuss with those interested afterwards. It has a unique time system on the bottom, which I didn't understand at first. And then I had some email correspondence with a famous historian of astronomy named Owen Gingrich, and he tried to explain to me. At first I couldn't understand it, but then I was able to place my mind in the mindset of these early cartographers and a light bulb, shown on me. The other thing that's interesting about this map is the date, 1727. That's fairly early for an eclipse map. It's the first, and it predated the first eclipse map in the United States by over 100 years. So the Mexican and Spanish culture at this time was considerably more advanced than the culture in present-day United States. The first eclipse canon is called the Eclipseum. It's not very well known. It's somewhat idiosyncratic. I have a copy of the original. It's written in Latin, and all the calculations are given in this beautiful book. But it stands as the first collection of eclipse maps for a considerable period into the future. It's not very well known even among people who know something about eclipse maps. Of course, the epic achievement in eclipse mapping was from Pulsar, the canon der Finsternisse. And the story behind this was Pulsar was an eclipse chaser himself. He had seen some previous eclipses, and he had done some astronomical studies. And he took it upon himself to organize this massive undertaking of creating a canon of eclipses over, I can't remember the exact span of time, but it's well over 1,000 years. This is one of the pages from his atlas, and he used 10 computers to generate this atlas. 10 computers in 1887. Back then, computers referred to a person doing calculations by hand. So we hired a team of 10 people to do the calculations. Of all these thousands of eclipse tracks that are mapped in this canon, he commuted the begin point, the center point, and the end point, or his team did, and then he drew curves through them. So they're roughly accurate, but in some instances you'll see some deviations from reality, but still, to compile a canon of this comprehensive vision was quite impressive. In fact, this canon was not surpassed in its comprehensive nature until the year 1966, which I'll show later. This is one of the more interesting maps in my collection because this is a map of the famous 1912 eclipse, which was a very short duration eclipse, and it crossed the outskirts of Paris and some other places in northern Europe. What's interesting about this map is that you will see 5 different lines drawn. And these lines reflect the uncertainty at the time of the central line of eclipse. So rather than publishing one center line for an extremely narrow eclipse map, this cartographer wisely chose to draw the lines for all of the authorities of that time so that the reader can make the judgment of where they want to gamble and place their bet for where they could see this exceedingly narrow eclipse. This eclipse map, the 1912 eclipse, is also famous for being nearly coincident with the sinking of the Titanic. In my collection, I own a French journal of this time, and inside this, in this French journal, the eclipse is front page news. And if you open it, then you start reading details about the Titanic, but the eclipse was deemed more important than the Titanic. This is another famous eclipse. This was shortly after the outbreak of the First World War. The flames that you see are the front lines of the fighting. And you can see the eclipse path being drawn through there. Of course, eclipses have had an ominous nature among past peoples who didn't understand the nature of the eclipse. This is a very evocative, emotional eclipse map. And of course, one of the most famous eclipses of all is the one that provided the first supposed confirmation of Einstein's theory of relativity. This is the eclipse where Eddington made the first observation of the deflection of the stars around the eclipse due to the relativistic effects of the sun's mass. And I understand from some colleagues that while this is a very famous result, post-analysis, the consensus seemed to be that Eddington may have fudged his numbers a little bit or may not have accounted for the level of accuracy in his computations, because it was judged later on that his instrumentation could not have had the resolution to determine whether it was whether relativity was real or not. But still, it's a famous eclipse and a famous result. So these are some of the varied types of eclipse maps that have been created in the past. The 1927 eclipse was significant because it crossed over the United Kingdom, and it created a second flourishing eclipse maps and graphics, and placards were placed on buildings in this area so that people could know whether or not they were in the eclipse path. This is the successor to a pulsar cannon that I referred to earlier, and this is the first computer-generated eclipse maps. This was done by John Menes, who many of you know of, and his colleagues, and whom I had the privilege to have met last night at his home near Brussels. So his maps were created in the same form as a pulsar's maps, but he made some improvements. For example, a pulsar only mapped the northern hemisphere. And Menes and his colleagues mapped the northern and southern hemisphere, and also with greater accuracy in the tracks. Now, this is one of the very first eclipse maps that I created. And I created this in the immediate aftermath of a cruise, an eclipse cruise that I took. And this eclipse cruise, you can see the track of the ship. And in the lower right corner was our destination on eclipse day. We were sailing to the point of greatest eclipse. And some of you in this room I met on that cruise. This is the first time that I created eclipse mapping, even though I've been an eclipse chaser since 1991, and I have over 30 years in the GIS industry. But what happened with this eclipse was this cruise was advertised to go to the point of greatest eclipse. I had a GPS receiver. I wanted to keep the ship's captain honest. I wanted to make sure that we did get a good location. And so I brought my GPS receiver and collected this track, especially the details at the point of greatest eclipse, and I was able to verify that, yes, we were very, very close, within a kilometer of the theoretical point of greatest eclipse. So that was a big success. We had marvelous skies, while much of China was clouded out. So, a little bit of background. Some of you have spoken to me already at this conference asking me about my method for eclipse mapping. My day job is writing books and documentation on geographic data modeling. That's my specialty. My expertise is how to take any type of geographic system, whether it's a road network, a river network, a terrain field, weather, population, topography, and how to model that inside of GIS. And I've written a series of books in this field. This is one of the books I've written, Modeling Our World. This is a page from my book, and I include this page because it illustrates my basic technique. My technique begins with the inputting of geographic points that you see in the top panel. These points have a latitude, a longitude, and a z-value. When you make a topographic map, nearly all the time your z-value is the topographic elevation. But there's no reason why you can't use something else for a z-value. For example, you could use a rainfall level as a z-value and make a nice map that shows a distribution of rainfall. Well, I had the insight leading up to this 2009 eclipse to, instead of using elevation as a z-value, to use duration of the eclipse as a z-value, and contact times of the eclipse as a z-value. So I typically create about a dozen or so different sets of data like this. So just to tell you what's going on is, at the top is the raw data. The second panel is a step called triangulation. So we create a set of triangles in the software. That's an optimal triangulation between these points. So we have a collection of facets. The third one is where we start doing interpolation of these facets. So if we have elevations at the corners of a triangle, we can interpolate that elevation at any point inside that triangular facet. So this shows how we apply it to terrain, but I'm applying the same techniques and the same GIS software technology to create time surfaces of the eclipse. And the time surfaces are either duration or contact times, and I also do sun altitude and several other eclipse circumstances. There's more detail than this. One thing I would add to this is that with my colleague Xavier Julier, I worked with him several years ago, and he kindly made a custom adaptation of his solar eclipse maestro to output these points in a form that I could consume in the GIS software. And we also worked hard on, to make an accurate eclipse maps, you need many, many millions of points generated. You want a very fine gridded set of points. But we also developed a method so that there's a variable density of points, so that along the limit lines, it's very dense, and in the center of the umbral path, it's less dense because the duration surfaces alter or vary much less than they do at the limits. At the limits, it's like a cliff, it's very steep. So you want a lot of points near the limits. So in a nutshell, that's my method, and those of you interested can speak with me further on this. So this is an early eclipse map that I made for the annular total solar eclipse of 2012. This actually went right over our home in Santa Fe, New Mexico. This was on May 20th, 2012. At the time, I was operating a website called ECLIPSES.com. And ECLIPSES.com, I created and put these maps up, and I just put them up there out for the public. And I was surprised after Eclipse Day to see that the statistics for my website just went crazy. Without really trying, the maps and the website went viral and received a lot of coverage. So I thought, well, there's a total solar eclipse coming in 5 years, and that's going to be a much bigger deal than an annular eclipse. So the very next day, I went on GoDaddy.com, and I was very happy to find out that the URL greatamericaneclipse.com was available. So we snatched it, and together with my wife, we co-developed the website. I also created a number of maps for the transit of Venus, and some interactive maps, and created some maps. Basically took this map and translated it into 35 different languages so that the whole world could have a map in their own language. So as I said before, much of my work is done in collaboration or using the Xavier Solar Eclipse Maestro, and so I began precision eclipse mapping at this time. This is an example from the total solar eclipse in the fall of 2012. This map here is the 2013 annular total eclipse that crossed over Africa. And some of us in this room, and perhaps a few thousand people, traveled to Africa to various locations along. But I wanted to address the many millions of people that couldn't go to the eclipse, but they had a wonderful opportunity for a sunrise partial eclipse. So I made this specialized map as a guide to what they could expect to see just rising above the horizon at sunrise. So that's another form of eclipse map. I think you're getting the idea that there's a lot of variety, a lot of creativity, a lot of imagination. I'm a cartographer, and everything on a map that I produce is intentional for a given purpose. So I think about what the functions of the map ought to be, and then I design the map to achieve that function and deliver a certain amount of information, not too much, not too little, just try to hit a sweet spot of information delivery. Okay, this is a quick animation, and can we start the animation? I've also made a series of animations for lunar eclipses, and if you look on the globe at the right, you'll see that the globe is slowly turning. So it's showing the side of the Earth that's presently facing the eclipse. So everyone who is in this part of the globe will be able to see the eclipse at that moment. Okay. I also made a series of maps for the 2016 polar eclipse that was only visible from the Faroe Islands and from Svalbard. I was lucky enough to be in Svalbard to perfectly clear but incredibly cold skies, and just the most beautiful sight of my life. Normally, we don't like to rate your past eclipses. They're like children. We love them all. But this one was very special for me. I think the Svalbard eclipse has to be the number one on my personal list of solar eclipses. But Europe experienced a very, very deep partial eclipse at this time too. I did something fun for this 2016 eclipse, and I realized that a partial solar eclipse is a good proxy for what sunlight would appear from an outer planet. So if the sunlight diminishes by a certain amount, then you're seeing the same sunlight that you would if you were an astronaut on Mars or Jupiter or Saturn and so forth. So this is a fun map that hopefully does some scientific education as well. So if you couldn't see the total solar eclipse, you could at least say that I saw what sunlight on Jupiter would be like if you're far north in Scotland and so forth. And a particular problem for eclipses where the eclipse is very low above the horizon is you want to make sure that you're not in the shadow of the mountains if you're in mountainous terrain. So again, I drew into my GIS bag of tricks and created some specialized maps that show exactly where the shadows will be. This is Long European in Svalbard. And if you look closely at the map, you'll see that the only real settlement in Svalbard, which is Long European, was mostly in shadow at the moment of total solar eclipse. And most of the nearby airport was in shadow. But if you drove along the road into Untitled, the valley adjacent, then you had good prospects. So this was very informational and very well received up there. This is a map I made of the Indonesian eclipse. On this map, I drew a latitude and longitude grid, but only at sea, not on land, because at sea you don't have geographic landmarks. For example, on a regular map, if you're driving along the road, you can judge where you are by your position along the road network. You know, you're next to this particular city and so forth. But at sea, you don't have that luxury. So this is for people like me who have GPS receivers and are interested to know where they are. I did quite a bit of work for the 2017 eclipse. This is an overview map that I created for this eclipse. But I felt that this eclipse was the first major eclipse in a populated area during the social media era. So if you follow our Facebook account or Twitter or Instagram at that time and to the present, you'll see that we have fun. We create these meme graphics, and the meme graphics have an educational purpose. For example, the graphic in the middle, occupy totality, because 99% just ain't good enough. So that tries to get the message across that you have to be inside the path of totality. And it does it in a fun way instead of banging people over the heads. And also save the date. It's like a wedding announcement, except it's the union of the sun and the moon. Another popular map that I made at this time was to identify 10 great places to see the eclipse. That's one of the most frequent questions that we received at this time, is where do I go to see this? So this particular map also went viral and had been shared in a number of publications on social media. This is very popular, especially with the local organizers of the 10 places that I selected. I tried to make a representative selection so that all parts of the country were shown, even though I was personally biased towards the western half of the United States for obvious weather reasons. Okay, now can we show the first of the external videos? Okay, so I also had some fun with GIS software. And what you are seeing now is the real-time motion of the moon's shadow across the Grand Tetons in Wyoming. This is probably the most scenic spot along the eclipse path last year. And you are actually seeing the shadow and if you look closely, you'll see how the shadow drapes around the terrain. So this gives you an indication of how rapidly the shadow is moving across the Earth, along with some vital statistics of it. Okay, can we move to the next external video? Pardon me?
I closed something too much. There it is.
Oh, here it goes. Yeah, this is another view of that, and while this is going, we're going to take a quick tour across the United States. And I will tell you about some interesting features of this animation. It took 93 minutes to cross the United States. This animation compresses that to 93 seconds. So this is the actual shape of the moon's shadow draped across the terrain. You see how it's wiggling whenever it encounters some mountains. So there's two interesting features that you see here. One is you can see how the shadow is corrected for the terrain. But in the flatter areas, you'll see something else interesting. And let's see, we're going to come to the flat areas soon. You'll see that the general shape of the moon's shadow is not perfectly oval as you see in classical eclipse maps, but actually is characterized by a series of straight lines that join at inflection points. You can see that more clearly now. And the short story is that the lines are basically places where either the beginning or end of totality is dominated by one particular Bailey's bead. Okay, so one particular Bailey's bead defines the straight shape. What happens where two of these straight segments come together? Can anyone guess? You see a double diamond ring. And I've seen a double diamond ring before. It's a very spectacular, beautiful sight. So if one of your goals to see an eclipse is to see a double diamond ring, these maps that I'm creating now have the predictive power to tell you that if you want to see a double diamond ring, go to the inflection points and you'll see it moving there. But you want to still be reasonably close to the center line to keep the duration. But you'll see a nice inflection point just to the right of the center line as it evolves across the country. And we're in Kentucky now. I guess we should let it go through Carolina because we're almost there. But isn't that cool? I just love this stuff. Okay, now we're crossing the Appalachians, Georgia, Smoky Mountains, and we should see the Carolinas any second now. On the top, of course, you can see the local time and the speed of the moon's shadow. The moon's shadow is the slowest near the point of greatest eclipse. And now the shadow goes across. Okay. Earlier I said that on a map you want to present an appropriate level of information. You don't want to overwhelm your readers. So a solution when there's a lot of information you want to convey is to break it up into multiple maps. If you go on our website, greatamericaneclipse.com, you see many examples where we break out the individual eclipse circumstance into multiple maps so that you can inspect that at your leisure. Here's a quick map showing one past and 3 coming eclipses. All of you know about the 2024 total solar eclipse, and most of you know about the annular eclipse also crossing the U.S. in 2023. But an interesting annular eclipse occurs in, I believe it's 2021, in southern Canada. And if you've seen, well, yesterday actually, I think it was Jord, or one of the speakers yesterday showed stunning photographs of a highly distorted annular ring at sunrise. And I was astonished after I saw these photographs, and that instantly became a bucket list item for me, was to someday in my life to see a sunrise or sunset annular, to see that stunning distorted annular ring. Well, in North America, we have that opportunity in Southern California, in Southern Canada. It's a bit tricky because it's a wooded area with limited roads, but it is possible if you find a lake with the right orientation. And so I think many of us will be heading up there roughly near the sunrise line in 2021. Now, GIS, or I said earlier, is, you can think of it as smart maps. And you can do a lot of analysis in a GIS. So one of the things that I did was I created this very specialized map called Drive Times to the Center Line. And these are 2-hour increment bands. So these bands show from any particular location in the United States and Southern Canada. Unfortunately, I didn't have the data for Mexico, otherwise I would have included that. But it shows you how many hours it would take to drive the optimal path, or the optimal way to the path of total solar eclipse. This took a lot of computation. I was able to do it because I had access to some internal software, and I could use a lot of computer time. This took about 2 days of computation because I had to compute these bands for all the different, for 10,000 different locations, and then merge them together. So it was a process to create this map, but this map was very well received and created a lot of interest. Okay, can we start this video? This is another video. You know, the reason we call this the Great American Eclipse is not because America is so great, but because so many people are so close to the path of totality. More than half the population of the United States could reach the path of totality within a single day's drive. And so that's an amazing number. So this summarizes those statistics in a nice graphical form. This is another variation of the map that I showed you earlier. Instead of showing the bands of travel time, I'm showing the actual drive shed. Okay, people know what a watershed is. A watershed is the area that drops of rainfall will accumulate into rivulets and then streams and then rivers, and eventually at the mouth of the river into the ocean. And so this particular map shows the optimal drive path for anyone wanting to visit South Carolina. And the statistics that I calculated was South Carolina was the closest destination for 94 million people. And this is the optimal path for that. South Carolina was the top state in the country for accessibility to the eclipse. And this shows all of the drive sheds color-coded across the nation. Some of us were caught in traffic jams along these drive sheds afterwards. This shows some future eclipses coming across North America. I made the same map that I did for Europe that simulates sunshine on external planets or outer planets. It's a fun graphic. Practically all of the United States was Mars-level sunlight or memory. But you would have to get very, very close to have Neptune or Pluto-level in this. I basically, it was straightforward. It's straightforward to compute this. If all you need to do is to take into account the inverse square law, and then you can generate this. This map shows the unique circumstance of the 2017 eclipse. It's the first eclipse to cross the United States exclusively, and no other country since the beginning of the nation in 1776. There was one other eclipse that was a close call in, I believe it was 1918, but that one touched some of the Bahama Islands, so that was disqualified from the exclusive title. I created some commemorative art with a colleague, Zeiler. This is a map that I just created of Chile that's on display on the table and outside. Overview map of Chile, of this coming eclipse. Another shadow map, because similar to Svalbard, this eclipse occurs near sunset in the mountainous area, so this information is important. If you want more detailed maps, go on the website, it's all there. A nice map I made of the 2024 eclipse, also on display here, and you can get it through our website. And I will close quickly with these last 6 slides. This is a quick tour of the 2024 eclipse. This was published in a book by Fred Espenak and J. Anderson called Totality. So I divided the path of the 2024 into 6 segments, and what's shown is the duration of totality along the center line. A nice little inset map that gives you some context for this. And the 2024 eclipse ends in Newfoundland and Labrador. Thank you.